Hello, so today we are going to be covering big idea 4B, which is solution stoichiometry. The subsection of notes we are covering is dilutions. Okay, so please split screen, open this up. Okay, so we are going to be going over dilutions. So far you guys have covered a couple concepts, some of those concepts being molarity, concentration, solutions, solvent, solute, and how those affect those solutions. Okay, so far you guys have covered a little bit of each of those. Now, going forward, we're going to be talking about dilutions. So far you guys have talked about a concentrated solution, which is like your really sugary Kool-Aid, and a diluted solution, which is a very watery Kool-Aid. Okay, so what a dilution is it is the process of decreasing the concentration of a solution by adding more solvent. Now, all that really means is you're taking your sugary Kool-Aid, you're pouring water into it till it's watered down and not as sugary. That's what a dilution is. You're watering it down to make it less sugary. But the thing about it is, you still have the same amount of sugar in there before as you did after. Okay, there's not a change in the amount of sugar. All you're doing is adding more water. So that's the same thing with a dilution. The moles that are in there beforehand, so if you guys see all of these different moles, if you wanted to count all of these up, it's the same amount before as it is afterwards. Okay, so each of these different moles that we have in here is the same amount. We just have more water added. Okay, so our moles of solute, it's the same after the solution as it is beforehand. So now we're going to scroll down and we're going to check out our second figure we have here. So in this second figure, you'll see we have 0.2 0.02 moles of KMNO3. Afterwards, after our dilution, we still have 0.02 moles of KMNO3. All we're doing is we're taking our concentrated solution, we're adding water to it to make it more dilute. Okay, and so this is like what we saw yesterday with our very sugary drink, and then we're adding water to it until it's less sugary, it's more diluted. Okay, the thing that changes, since we add more water to it, is going to be a less concentrated solution. So our more concentrated solution on the left is 0.2 molarity, and on the right we have 0.04 molarity. So it's a lot less concentrated, a lot more dilute. Okay, so here's our equation for this. Our equation that we talked about earlier is our molarity is equal to moles divided by liters. Okay, so molarity equal to moles divided by liters. You guys already know this equation for molarity. Now, if we wanted to rearrange this equation, if we multiply both sides by liters, right, it's going to cancel it out over here. Then you have liters times molarity, so liters times molarity is equal to moles of solute. All you're doing is you're rearranging this equation from up here. So your moles of solute is equal to molarity times liters of solution. So, since the number of moles of solute remained unchanged upon dilution, we get this new equation that's equal to the molarity of our first, so the molarity of our initial times the volume of our initial is equal to the molarity of our final times the volume of our final. Okay, so if we're looking at this, the only reason why that works is because our moles are equal to each other. So since we have the same amount of moles in both of these, we can set these equations equal to each other and end up with this new equation. M1V1 equals M2V2. And that is our dilution equation, where M1 and V1 are the initial molarity and volume. Volume is liters or milliliters, guys. So M2 and V2 are the final solution's molarity and volume. So after that dilution happens. One important thing to note from this. So units can be liters or milliliters as long as they're the same units for V1 and V2. So if V1 is in milliliters, then V2 has to be in milliliters. If V1 is in liters, then V2 has to be in liters. So you'll come to realize that as we go through a couple examples, you'll see what I mean. So our first example, it says how many liters of 2.0 molarity sodium chloride would you need to make 1.5 liters of 0.5 molarity sodium chloride. Okay, so the first thing we need to do, we need to recognize that this is a molarity or a dilution problem. Okay, so since a way that we can recognize that this is a dilution problem, an easy way you can do to recognize that is if you ever see 2 molarities in a problem. So generally, if you see 2 molarities in a problem and there's no equation or reaction in there, you can generally think this is probably going to be a dilution problem. Okay, so if we look at this, what it's really asking us is if you have 2.0 molarities of this liquid, so this is a 2.0 molar liquid, how many liters of that would you need to have initially in order to have 1.5 liters of this 0.5 molarity liquid? So if you want to have 1.5 liters of this 0.5 molarity liquid in the end, how many do we need initially? So this is how we figure that out. So you have your M1, because this is your initial. Okay, liters, this is going to be your V1, because this is what we are looking for. Then you have your V2 and your M2. So we set our equation, M1 V1 is equal to M2 V2. We plug in what we know, 2.0 molarity times V1 is equal to 0.5 molarity times 1.5 liters. So if you divide both sides by 2.0, that'll cancel out over here, and you get V1 is equal to 0.5 times 1.5 divided by 2.0. And what you get for that, you end up getting V1 is equal to 0.375 liters. After sig figs, it should be 0.38 liters. Alright, so that's our final one. And since we have our initial is in liters, that's how we know that this final is going to be in liters as well, because they have to say the same. So based on this rule up here, if we have one that's liters, the other has to be liters as well. So all that means is that we initially had 0.38 liters. Okay, and if we wanted 1.5 liters of this dilute solution, we started off with this, and then we added solvent until we got this. Okay, so this is what we wanted in the end. Okay, so now in our second example, it says, how many milliliters of 12 molar HCl would you need to make 175 milliliters of 2 molar HCl? So the first thing we need to do is we need to identify our different variables. Okay, so we're trying to make this. So this is going to be our V1 and our V2 and M2. So this is going to be our M2. This is our second molarity, and this is going to be our V2. Okay, so whatever our initial is, that's usually the weak or the stronger one. It's our concentrated solution. So that's going to be our M1 over here and our V1 over here. We're looking for it in milliliters. And remember, our units have to stay consistent. So we start off making our equation. M1 V1 is equal to M2 V2. We plug in what we know on this. We have a 12 molar solution. We have V1, which is unknown, is equal to 2.0 molar times our V2, which is 175 milliliters. Now if you divide both sides by 12 molar, that'll cancel out over here. You get 2.0 times 175 divided by 12, which is going to get you a V1, which is equal to 29.16 milliliters, or 29 milliliters, because these has our least number of sig figs. That's only 2. So our final answer is going to be 29 milliliters. So what that's saying is that if you want to have 175 milliliters of a 2 molar solution, if you want to have 175 milliliters of this 2.0 molar solution, you need to take 29 milliliters of this 12 molar solution. You need to add solvent in it, so you need to add water until you get to 175 milliliters. So that's how you can make that dilution. Alright, now our third one, this is our last example. It says, what is the final concentration, so we're looking for a final concentration of a solution if 550 milliliters of 2.5 molar KOH solution were diluted to a final volume of 750 milliliters. Now this is a little, like the way they word it, it has your M2 in the beginning and your V2 at the end. The reason why is it says final concentration right here, final volume right here. Okay, so you got to make sure you can pair those together. That means this is your M or your V1 and your M1. Okay, so now you can plug it straight into your equation. M1 V1 is equal to M2 V2. Okay, so if we have a initial concentration of 2.5 molar and an initial volume of 550 milliliters, and you have a final volume of 750 milliliters with an unknown concentration, then divide both sides by 750. They'll cancel that out, and you'll end up with a concentration that's equal to M2 equal to 1.83 molarity or 1.8 molarity. Sorry for the slanting writing. I think I lost track on my screen. Alright, so we have a final concentration of 1.8 molarity. Again, what that means is if you have 550 milliliters, okay, so you have 550 milliliters of this 2.5 molar KOH solution, and you want to have 750 milliliters of that solution. What's going to be that final molarity? So how do we solve for that? We do that, okay, we get a final concentration that's equal to 1.8. Okay, so you add 200 milliliters of water in there, and we end up with a solution that has 1.8 molarity concentration. So that's all that means. That's all these dilution problems are. There's not too much to them. Make sure you guys practice. Let me know if you have any questions.